Hello everyone, myself Ashish Desai, Assistant Professor, Mechanical Department. Today we are going to discuss here unit number 2, Embedded Engineering User Interface. So in that content we are going to discuss here the user interfacing with 3D printer. So first of all we look at the user interfacing. So user interface is a portion of interactive computer system that communicates with the user. So that's why the user can easily understood and communicate with the software. So that's why it can create a different tools, and with the help of these tools we can create a geometry, or can say we can create encoding system, and then we are to formalizing the machine language. So that is why the user interface is becoming a larger and larger portion of software in a computer system, and more important portion as a broader groups of people use computers. So as a computer becomes more powerful, and the critical bottleneck in applying the computer based system to solve the problem, and often a user interface, so which is rather than the computer hardware or software. So this is the regarding the user interface. So we'll take example of 3D printing, so how it communicate with the user. So first of all we approach for the modeling to 3D printing, so how it can perform. So first of all we create a model in a 3D software, so with the help of the computer system. So if you create this 3D model, then we are fed into the CAD Cura software. This Cura software is nothing but the slicing software. So slicing means you have to slice into different parts, or can say different layers, and this is called as layer by layer manufacturing. So if you're slicing of this component, then we have to convert this Cura software to convert G code, and G code means the machine code. So that's why we have to create this G code, and this G code file we have to feed into the memory card, and this memory card we can directly attach to this 3D printer, and according to that motions, or can say G code language, this nozzle will perform uh, that vertical task and complete this physical object. So this is the regarding the approach towards the modeling to 3D printing. So in 3D printing, actually, this is the filament. So this is a filament, or can say wire, and this material is PLA and asbestos. Anyone you can select. And here, this is the nozzle. So here, look at this nozzle over here. So this arrow indicates the nozzle, and if you fade this filament, then that melting will takes place in the nozzle because of heater is placed over here, and after hitting this melted portion, or can say molten pressure, that fluid or liquid will be comes from this nozzle, and according to this G code nozzle will move x and y and z directions, and according to that it performs a specific task and complete this that final product. So this is the approach for modeling to 3D printing. So this 3D printing is nothing but additive manufacturing, or you can say layer by layer manufacturing. So here we are creating a physical object. For the purpose we required 3D modeling software, then slicing software, and after that we have to fed into the that 3D printer with the help of memory card. So this is the user interfacing. So user interface for the 3D modeling is you have to using different commands like a line, then you use a rectangle, then you use the different commands with the 3D printer, sorry 3D software, and according to that formulation of the component is there. So here user interface user will be find different tools for creating this job. So here also in Cura software also we require the user interface, because according to our usage we are to slicing this component, and then we are to formulating G code. So this G code is nothing but machine code and directly fed into the 3D printer. So here there are different user interfaces there. So how it is interface with modeling to 3D printing. So here first of all we discuss in the three stages. So in the first stage we have to create a model using 3D printer. So first of all we create a 3D model with the help of 3D software, and in the 3D software are develop a component, and this simply we have created 3D design files. So in 3D software, as you know that different tools is there, and with the help of interfacing with this that software we are clicking and dragging, selecting and dropping, as well as we are to extruding. So number of operations we are performing in that model and software that will help to create a final shape. Suppose we are considering this simply component. So simply component we are formuling using 3D software, that is Fusion 360 or CATIA software we use. So according to our requirements or according to our ability, we can use the software, that is 3D software. So here I used the Fusion 360 software. So first of all, we enter into the Fusion software and create like this shape. So this shape we will formulating this final shape. Okay. So first of all, we enter the design workspace. So design workspace is there. According to that, we have to create a geometry. Select this face. Then according to that, we have to create this in a rectangle shape, center point rectangle. So center point rectangle is there. We are entering to 80 mm. Then tab button you can press it and 100 mm. So here require 100 mm. Okay. So enter. Again use this circle because we are required this shape. So for that purpose we use this shape like this. Here after pinching, you have to create this circle part. After that finishing is there. Then modeling for this, create this shape and extrude. So extrude is there. Say OK. So this is the final shape. This is actually simple part we have created over here, and then we have to save this. Save 456 as it is 456. Save it. So this is the portion we have to save, that is 456 in a file name. And then next, now next slide is the, or you can say next step is you are creating the slicing software, that is the, but we have to slice this component slice. That's why required a .stl file. .stl means standard triangular language file. We have to create this, and then you have to convert this G code by using Kira software. So first of all we create a .stl file, so that will help to slicing this, and then after this that nozzle will create a layer by layer manufacturing. So this will be create a software. So here this file we can save. After saving, export, we are use this. Export is there, and here to save this as the file name, and here .stl file we can save, that is standard triangular language. We save it, and here we can select the location. Suppose we require location is okay, then directly export. Directly export. After exporting, we will get the file. This is in a, that is in the format of STL format. So this is STL format we are formalizing, and this will be open with Cura software. So actually we are installed directly Cura software. Okay. So if you consider here Cura software, so that is actually Cura software is there. Here X, then next file install. So likewise we are installed it here. So after installing, we can directly open this file. That is, what is the file name? That is 456.stl file. Directly open this file. Then next, finish. So after that, we will get the next and finish. So this will help to open this Cura software. So some time we wait for this. Okay. So here after you can take open with the software name is Cura. Okay. So this is the Cura software. We can open it. File, then load model file. It is on the desktop mode, right? So if you select desktop mode, and here we select that it is directly 456. So this is the formulation job there. So it, if you rested on this side face, will require 2 hours and 20 minutes, and 38 grams material is there. So for that purpose, after we have reduced this time by setting, or you can say we can change the facing size also. We change the face, so put was 21 seconds, 20 minutes is there. So if you take a rest or like this, sorry. Okay, so like this we arrest it. So it requires 2 hours 60 minutes. Okay, so like this we are to setting here. So for setting purpose, we enter this setting purpose. We know that the quality we require, the layer height is, we can adjust shell, how to wall thickness is there, we can according to that set there, infill material is there, how much density is required. So according to our usage or our requirements, we can fit this, and this will be help to formuling this component. Okay, so this is the component, and here we are changing the setting. Here color is there, fill is there, speed and temperature is there. Suppose your material, that material is PLA, so we can take 200 degrees centigrade. If you take asbestos material, you can take 210. So according to our requirement, and we can change this temperature mode, their filament size, then flow percentage. So likewise we can change directly, and then we have to formuling the component. Okay, so this will help the layer manufacturing. So if you see like this, you can change according to that, and formulation of this component is there. Okay, so this is the final component, and this component is formulating by the Cura setting. Now we enter for the 3D printing process, that is printer. So first of all, we create this G-code file. G-code file is required. So again, go to the Cura software, then file, save G-code is there. Save G-code, then desktop 456 G-code is there. Save it. Directly you can open this. Okay, so this is the open file, and see this. So this is the G-code which is converted in the that software, that is Cura software. So this is a file in the format of G code. This file we can directly fed into the memory card. So here I mentioned the memory card, and then we have to directly insert to the machine, and the after that start the machine and convert into the physical object which is corresponding to the digital design. Digital design means that 3D software design. So this is the final approach. So for the final approach purpose, we have to create a 3D model file, then slicing with the Cura software, and this is the fed through the memory card to the 3D printer, and after that formulation would starts, and then final object is there. So this is the process start to end. Now how it creates, like that's why we have to interface with the 3D printer. So with the connection of this that memory card, we are to having a different setting is there, heater temperature is there, bed temperature is there, and then normally we have to do manually XYZ directions movement, and after that we have to setting for 00, and then as per like a CNC machine we are to setting for 00, that is our origin point, and then after that we are inserting this information or in the G-code format, directly forms the that formulation, I can say printing. So how it is possible, so check it. So this is the 3D printing is possible. Directly we can formalizing that form components. Likewise we can form a shape, different shape. So here I stop here, that in that session this is the nozzle, and from above the sides the filaments come into this nozzle. Due to the nozzle that heater temperature that melts the filament, and after that it can melting part of this filament, it should be convert this component. So this movement of this nozzle, it is fed through the G code. Okay, so this is the formulation. Check this. Likewise this formulation, that is nothing but layer by layer. So first layer, second layer, third layer. Likewise this component is formed. Okay, so this is the regarding the 3D printing. So here we are interfaces with number of ways, that is by hardware, then software, So likewise we have to interface, and then usually we have to manufacture the component. Now advantages of 3D printing. So as you know that the possible to manufacturing every complex design. So in traditional methods it is difficult to formulation of the complex design, but in case of 3D printing only we have to draw the model into the 3D software and directly fed into the memory card after conversion of .html file, then G-code file, and then directly formulate the component. So this is the first advantage of the 3D printing. Then easy customization. So according to the customer need, I can directly identify it and customize the component. And this is the methodology for conversion of the 3D model. So digital 3D model to directly physical 3D model. So this is the easy customization. Then lower fixed cost. Suppose if you create a new product or new launch product is there, if you go for metal casting and injection molding, that will be more costlier. But if you go to that 3D printer, it gives the lower fixed cost. The next advantage is the speed and easy of prototyping. So we can create a 3D printing as in a faster manner. If you create a easy of prototyping, then less waste. So this method is actually called as a additive manufacturing, or you can say layer by layer manufacturing. So that will help to minimizing the waste. So this is the that 3D printing material can also nowadays it is will be recycled and repurposed into the 3D printed objects. So this is the advantages we have to know for the 3D printer. Now we move for the next point for conversion process. Okay, so this is the interfacing methodology. Already we discussed this 3D printer. So as we know that 3D printer directly you can open it like this. So here this is the line one manufacturing is there. We can directly formulation and component with the forms. So here as we know that the G code. So this is the G code. So how it gives the information, actually a base setting is there, that layer height is 0.25, wall thickness is 0.8, then fill density is about the fill that is the 30, then part time is required 2 hours 70 minutes, filament used for this is 37 grams, then for that fund filament cost, if you mention directly into the machine directly we give the values. Then according to the this component that creates a geometry, and this is the help to create the G code and N code. So this is the approach towards the manufacturing of 3D model. So this is called as user interfaces with the 3D modeling. So here this is the approach. Here we have to more focus on this slicing software. So in slicing software, that is nothing but Cura software. So you can easily observe this part. So this is the layer, first layer, second layer, third layer. So as we like that, that component will forms easily. And after this completion of this part, we can directly fade into this software. That is the Fusion. That is the 3D printing software. Now we know that the this slicing software is having different features. Layer height, so maybe layer height is 0.25, then shell thickness 0.8, then bottom or top thickness that is 0.6 we have adjusted over here. Then next is the, yeah, I can mention directly, that is the bed temperature. So bed temperature is always remember that 60, because it does not stick directly the components material. So that is why I can adjust like this 60, and according to a requirement the printing temperature you adjusted. For PLA material you can adjust 200, as we saw is there that you can take 210. So as we like that, the suppose you have filament size 2, then you can insert directly 2, then flow percentage we require 100%, you can take 100, and then this is the advanced setting is the speed, distance, then quality, initial thickness, initial layer width is there, cutoff object bottom is there, speed travel is there. So as we know that we can directly fade and complete this component. Then minimal layer time is also mentioned here, that is 5 minutes, or sorry, 5 seconds is there. Enable full that cooling system is there. Then start to end coding is there. So according to that you can directly attach. So this is the formulation. Again, I check it. So this is the final component we have to form like this. This is the component we are forming. Thank you.